So the solution to this differential equation, it's very nice. Well, it looks very nice. That's why I want to share this with you guys. We have dy dx is equal to y plus y over x plus y over x ln x. And we have the initial condition, y of e is equal to e to the e. And before we start solving this differential equation, I just want to mention that we can define the solution to be on a certain interval, because sometimes you want the solution to be continuous. In this case here, you see that we have ln x on the bottom. So first note that x has to be greater than 0 because it's inside of the natural log. Secondly, x cannot be 1 because otherwise ln 1 is 0, dividing 0 is undefined. So either we can pick from 0 to 1 or 1 to infinity. Let's just go with 1 to infinity. So just say we want the solution to be on the interval 1 to infinity, not including the 1. With that said, here we go. Firstly, everybody here has a y. Let's factor that out and divide both sides by y. So we have 1 over y dy, just kidding, dy, and then multiply both sides by dx. So we have 1 plus 1 over x plus 1 over x ln x, and then dx here. Now we can just integrate both sides, this and that. On the left hand side, we have ln absolute value of y. We do need the absolute value right here. But on the right hand side, integrating 1 in the x world is x. Integrating 1 over x, we get ln x. We don't need the absolute value because we know x is 1 or bigger. Well, actually, x is greater than 1, sorry. Yeah. And then continue. Plus, here, for this integral, we'll do a quick u sub. Right here, this is going to be the u. And then you can see that du is equal to 1 over x dx, which we have it right here. So we are just integrating 1 over u in the u world. We get ln u, and u is ln x. And on this interval, this will be positive. Again, we don't need the absolute value. And then here, let's start to put down c1. Earlier, we didn't have to do that because if you did put a c1 here and then c2 here, you can combine them and call that c3. It will always happen, so just start with the constant on the right hand side. Now, here we go. Firstly, right here we have to exponentiate both sides so we can get rid of the natural log here. So on the left hand side, we have absolute value of y, and on the right hand side, they're adding in the exponent, so we just separate them. We have e to the x times e to the ln x times e to the ln of ln x, and then times e to the c1, and here we go. C1 is a constant, e is a constant. A constant to a constant power is still a constant. Let's call that c2. Good. Then we are going to get rid of the absolute value around the y. How? You really just get rid of it, like this, like that. But of course, on the right hand side, you have to remember to put down the plus or minus. Here we go again. Positive c2 is a constant, negative c2 is a constant. We can just put them as another constant, c3. So we can say y is equal to c3, right, because of this and this. And then this right here is just e to the x, and this right here, they cancel. We have x, and then they cancel, but this is ln x. That looks pretty nice, huh? We have x to a first power function, and then e to the x function, and also natural log function. Very nice. Now let's just go ahead and solve for c3. And since this is pretty much it, we don't have to use the subscript. And let's solve the constant here with this initial condition. Because we know y of e is equal to e to the e, so we can put e to the e for the y, and that will be equal to c, and then times e, and then this x is e, and then put e into this x as well, and then lastly we have ln e. Now check this out, both sides has e to the e, so we can just reduce that out, and then ln e is just equal to 1. So we see that 1 is equal to c times e. Divide both sides by e, so we get c is equal to 1 over e. Or if you would like, you can put it as e to the negative 1. Yeah. Okay, so c is just equal to e to the negative 1. And of course, this right here also has base e, so you can just add the exponents together. And finally, ladies and gentlemen, here is the answer. Y equals, let's put on the x first, and then e to the x power, and then along with the minus 1, and then we have natural log of x. As I told you, how pretty is this? That's the solution.